Hello, sir. This is I'm doing an assessment on collisions, chapter 10, and here we have a problem where a car has a mass of 2,300 kilograms that collides with the truck with a mass of 4,300 kilograms. And just after the collision, the car and the truck slides around together, stuck together, with no rotations. And here in the question, we are given the car's velocity before the collision and the truck's velocity before the collision. So uh, first, they're asking us that your first task is to determine the velocity of the stuck together car and truck just after the collision. What system and principle should you use? So they're asking what system and principle. So the system here is basically the car and the truck. That's it. So that's the system. And the principle, so the principle which I would be starting off will be the momentum principle after the choices which is given. So yeah, car plus truck and momentum principle. And for part B, we are asked to find what is the velocity of the stuck together car and truck after the collision. So here, I started by finding the initial momentum and the final momentum. So we know momentum is nothing but mass times velocity. So since there are two of them, so it's mass of the car times mass of the mean velocity of the car plus mass of the truck times velocity of the truck. So by multiplying, finding these two, we get the initial momentum. And for final momentum, it's after the crash. So after the crash is mass of the car plus mass of the truck. They both are combined together because they're crushed. So it's them both together times the final velocity. So since there is no other forces, external forces acting on it, we can take this as a linear momentum of a system. So we know that it's P initial is equal to P final. So by setting these both equal to each other by that and solving for velocity, the final velocity, we can get the velocity after the collision. So there's nothing but final velocity is equal to mass of the car, mass of the velocity of the car plus mass of the truck, velocity of the truck, divided by the mass of the car and mass of the truck plus. So to solve that equation which we just found derived, we have all the information given in the question. So it's basically just plugging it in right now. So by plugging in all mass of the car, velocity of the car, mass of the truck, velocity of the truck, mass of the car plus mass of the truck, like I set it up right here. And by solving it, I get the vector 2.8, 0, 17.6 meters per second. So that's the velocity of the car and the truck after the collision. So that's part B. And for part C, we are asked, in your analysis in part B, why can you neglect the effect of forces of the road on the car and the truck? We can neglect it because the gravitational force acting on the car-truck system opposes the normal force exerted by the road on the car-truck system. So they basically cancel each other out. And since the time limit we take is really small, we can basically neglect it. That's why we can neglect it. So that's the answer for part C. And for part D, we are asked to find what is the increase in internal energy of the car and truck. And okay. So to find the increase in internal energy, I started off by finding the velocity of the car, which we already have, which was given in the question to be 38,0,0 meters per second. So that's the velocity of the car. So first of all, I took that and I found the magnitude of that vector. So once I found the magnitude of this velocity vector of the car, I found it to be 38 meters over second, and I did that for the same. I found the velocity, the magnitude of the velocity of the truck, and I found that to be 31.4 meters per second. So once I found the magnitude of the velocity, then I took this formula where K is equal to the total kinetic energy of the car truck system before the collision is 1/2 mass of the car, velocity of the car square, plus 1/2 mass of the truck, velocity square of the truck. So we know mass of the car to be 2,300 kilograms, which is in the question. And here we just found the magnitude of the velocity of the car to be 38. So I got that and squaring it. And the same thing for the truck, which we just found to be 31.4 meters over second. And the mass of the truck is 4,300. And by solving it, I got the total kinetic energy before the collision to be 3.78 times 10 to the 6 joules. So once I found that, I found the magnitude of the velocity of the car truck system after the collision. So it's basically the square root of 2.8. This is, I have to tell you where I found this value. So this is the final velocity which we found. So I'm just taking the magnitude of this final velocity. So once I take the magnitude of this final velocity, I get the value of 17.8 meters per second. So after I found the final velocity, I found the total kinetic energy of the car truck system after the collision. So it's basically 1/2 mass of the car plus mass of the truck times final velocity squared. We know the final magnitude of the final velocity, which we just found here, and the mass of the truck and the mass of the car we know. So plugging it in, and by solving this, I got it to be 1.05 times 10 to the 6 joules. And now we have all the information to find the increase in internal energy. So the formula which I use for internal energy is nothing but the total kinetic energy, the initial, minus the final. Final kinetic energy. So we found the initial to be 3.78 times 10 to the 6, and the initial to be 1.05 times 10 to the 6. And by solving this, I found the increase in internal energy of the car and the truck to be 2.73 times 10 to the 6 joules. So that's part D. And part E, it asks, is this collision elastic or inelastic? So I said this that it is inelastic because after the collision, the car and the truck are stuck together and they move as a whole. So that's why it's inelastic. And that'll be it. Thank you.